This is a podcast on percent composition, empirical formulas, and molecular formulas. So if we look at the percent composition of KMNO4, potassium permanganate, we would want to find out what percentage of this is potassium, what percentage is manganese, and what percentage is oxygen. So the first thing we have to do is add up the molar mass of the whole compound. So we'd add up 1K plus 1Mn plus 4 oxygens, and we would look at the mass on the periodic table and then add them up. And that adds up to 158.04 grams per mole. So that's the molar mass of KMNO4. So now if we want to find K, we just do essentially K divided by the whole thing, KMNO4, and I'm talking about the masses of these, which would equal, K is 39.098, got that from the periodic table, and those are grams, divided by the total mass, which is 158.04 grams. We divide them and we multiply 100 to get a percentage, and that is about, let's see, 24.74% potassium. So about 25% of this compound is potassium. Now if we're to find the mass percent of manganese, it'd be the 1 manganese over the KMNO4, and the mass of manganese is 54.94 grams, and again we go back to that KMNO4 number, 158.04 grams multiplied by 100, and that equals about 34.76%. Now let's look at oxygen. You have 4 oxygens, so we'll have 4 oxygens divided by 1 KMNO4. So 4 times oxygen, which is 16, so it's 4 times 16, that's 64 grams on top, divided by 158.04. Again, that's the molar mass of KMNO4. We multiply by 100, and we get 40.50%. So the largest percentage of this compound is really oxygen. So of this compound, most of it is oxygen, but not that much more than the other ones. And so those 3 percentages should add up to about 100%. Sometimes it's a little more, sometimes it's a little less, based on how many digits you used and where you got your numbers from. Now we're going to talk about empirical formulas. I call them EFs, and molecular formulas. So if we were to have water, which is H2O, that is as simple as it can get, is as reduced as possible, a 2 and a 1. Perhaps you could have a molecular formula, which is really quite strange. If you multiplied it by 2, you could have H4O2. So the molecular formula for water would be H4O2, which really doesn't make any sense. But the point is that the empirical formula is the most reduced by the subscript numbers as possible. And the molecular formula is possibly not the most reduced. It could be the most reduced, but it generally means it is some whole number ratio of the empirical formula. When doing problems that ask you to determine the empirical formula, you always want to think of getting to moles, and there is a weird trick to doing these problems. Just follow along and see if you can get it. I'm actually working on worksheet 4 from your worksheet packet, and I'm going to work on the first one, and it says a new compound has been prepared, and it gives you the grams, so I'm going to write down the grams. So we have a compound that has 19.1929 grams of carbon, 0.1079 grams of hydrogen, and 0.08566 grams of chlorine. And when you do these problems, it's really important to use a lot of digits past the decimal. If you don't do that, sometimes you'll get the wrong answer. So the first thing we want to do is change everything into moles. When you start doing these problems, you will notice that you'll start getting some similar numbers. For example, this number and that number are very similar, and that's a good trend to see. So our next step, after we convert all these grams into moles by dividing by the mass, the molar mass from the periodic table of each element, carbon's 12, hydrogen's 1, Oxygen is 16. I messed that one up. It's actually oxygen. And chlorine is 35.45. We get these numbers and carry out lots of digits, or you will possibly get the wrong answer. Now, the next step is totally weird. We're going to kind of find the ratio between them all. We're going to divide by the smallest number, and the smallest number we have here is this number or that number. So we're going to divide them all by that number, which means these two numbers will be 1, which is great. So let's try that. So when we divide by the smallest number, that means we have 1 chlorine here. That one gives us 1, I'm going to write backwards here, 1 oxygen. This one over here gives us a 1.99, which we'll call 2 hydrogens. And this one up here gives us 3 carbons. So that actually ends up becoming our formula. So what do I mean by that? That means carbon's first, because it was given to us first. So carbon, we have 3 of them, so we write C3. Now we have hydrogen, because that was written next, and we have 2 of those. And then we have oxygen, so I'm going to write O next, and we have 1 of those. We don't need to write the 1, but you can. And then the last one is chlorine, and we have 1 of those. So the formula is C3H2OCl, and that is called the empirical formula. It's kind of a cool trick. So let's review what we did. We first of all wrote down our numbers in grams. We converted them to moles for each one. We looked at them and found the smallest one, and then divided these all by the smallest one, such that we got whole numbers. And if we don't get close to whole numbers, there's a trick for that. I'm not going to tell you quite yet. But all these numbers came out really nice, 3, 2, 1, and 1. And then we wrote the formula, and that's the end of the problem. Now I'm going to do another problem on that worksheet number 4. It's actually problem number 3, and it's given to you in percentages. The easy thing to do is just call it grams. So if you're given like 33.88%, you can just call it 33.88 grams. And again, we'll change grams to moles, divide by the smallest, and then write out the formula. So when you do the math, we're given this amount. We divide it by the mass of copper on the periodic table, and we get that many moles. And then nitrogen is that given to us, divided by the mass on the periodic table, and we get that. And there's the oxygen given to us, and we divide by the molar mass from the periodic table, and we get that. Now we inspect them and find the smallest number, which is this one, and then we divide them all by the smallest. So there's the smallest, and we luckily get nice whole numbers, 1, 2, and 6, and that leads us to writing the formula, which would be copper's first because it was given to us first. So there's 1 copper. We don't need to write the subscript 1. Then we have nitrogen, which there's 2 of those, and then we have oxygen, which there's 3 of those. So the formula is CuN2O3. And that is the empirical formula. So let's say after you have changed it to moles divided by the smallest, and these are the numbers you get, like 2 carbons, 1.5 hydrogens, and 3 oxygens. You clearly cannot write a formula that is C2H1.5O3. But if you keep the right proportion, you can write it. So if you think about 1.5, how could I make that a whole number? You'd multiply by 2. If you multiply this one by 2, you got to multiply them all by 2, so it would be C4H3O6. So again, C4H3O6. So let's say you had these numbers instead, like 1.25, 2, and 3. And you cannot have a 1.25. I think of 0.25 and what fraction it is. It's 1/4. So if I multiply these all by 4, then I'll get whole numbers. So let's say, for example, your numbers were actually a third, like 1.33, then you had 3, then you had 5. You can't leave this fraction like that. I think of that fraction as 1/3. I think of the number on the bottom, and then I multiply all of these by 3, and I'll get whole numbers. So the other possibility would be 0.75, and 0.75 is really 3/4. So you would multiply all your numbers by 4 to get rid of that fraction on the bottom, and then you'd end up with whole numbers. Now I'm going to look at problem 6 on worksheet 4, and I'm going to tell you what the answer is. The empirical formula is C2H2ON. And so you go through all the work to do that. And part of the question actually asks you, what is the molecular formula? So the molecular formula is going to be a formula that is a multiple of the 2, and the 1, and the 1. And what you do is you do the molar mass of the molecular formula divided by the molar mass of the empirical formula. And the molar mass of the molecular formula is given in the problem. It actually says 165 to 170. I'm just going to choose 168. So the bigger number always goes on top of this problem. And then the empirical formula, you add up 2 C's, 2 H's, 1 O, and 1 N, and you'll get about 56 grams. This is probably the only time in chemistry where you can round up numbers nicely. So 168 divided by 56 means that the formula on top is 3 times as large. So you go up to here, and you'll multiply that by 3, that by 3, that by 3, and that by 3, which gives you C6, H6, O3, N3. So that is the molecular formula, and the one with the 2, and the 1 is the empirical formula. Well, that is the end of percent composition, empirical, and molecular formulas. I wish you well.